moments. What are they? How do you calculate them in trusses? Moment is a rotational force. That's the big thing. Rotational force means that it will go around as you apply your force around this pivot point. Okay, so this is what you have. You have it, a distance, a pivot, and some force, and that is applied here, and then everything will go around this way. So I have my rotational force. And what that is, and there's my formula, force times distance. The force applied times my distance. The distance has to be perpendicular at a right angle. Okay, that's really important. It has to be perpendicular to the distance. You'll see it here. Okay, it has to be perpendicular. So, two kinds of moments, clockwise, counterclockwise. Counterclockwise is positive, clockwise is negative. It's just the way it is. And in order for something to be in equilibrium, equilibrium means it is equal, means the forces are equal and opposite, they're balancing each other out. So by balancing each other out, my clockwise moments have to equal my counterclockwise moments in magnitude. So the sum of those, my Greek sigma right here, sigma moments equals 0, sum of the moments equals 0. So all of the moments have to balance each other out. For every, you have to have equal and opposite clockwise, counterclockwise moments. So if I have my seesaw here, teeter-totter, I got a big bear, got a little bear. That's not going to balance out. Big bear is going to be a bully, little bear is going to be stuck up in the air. But if we move them in a little closer, so now this distance here is going to be less than this, clearly, right? I think we understand that. So we want to figure out, what is this distance? Well, if we look at it as moments, I have a, if you look at, you can see right here, I have a negative clockwise moment. This guy's going to push it around this way clockwise. He's a negative moment. The little guy here is going counterclockwise. He's going to be a positive moment. So they're going to balance each other out. So if we look at them as putting them on either side of an equal sign, then what I have is my moment 1 equals moment 2. And the definition for moments was force times distance. So F1 D1 equals F2 D2. Okay, so that was 25 pounds times 4 feet equals 40 pounds times my D2 that we don't know. Okay, so 4 times 25, so I've got 100 equals 40 D2. D2 is 100 over 40, so D2 equals 2.5. Okay, so this would be 2.5 feet. He's got to move in 1.5 feet in order to balance his buddy out. And that's moments. So that's pretty simple. That's a very simple one. What we're going to be looking at are moments that look more like this. Ooh, ah, okay? But it's still the same thing. Now, haven't explained yet that these are different kinds of supports. That is a roller support. This is a truss. Roller supports have a single force pushing up on it. This is a pin. A roller has one force. A pin has two forces. You're going to see this over and over as we go through moments and then as we get into the more involved trusses. So the way that this works, I'm going to do it one way, then I'm going to show you what I consider the foolproof, simple way of doing it. So I come up here. Again, what I do is I've already replaced my pin and my roller with the respective reaction forces. The whole purpose of this is to be able to find those three reaction force unknowns. We want to find this, this, and this. This is what we're trying to solve for. What I want to do is I want to pick a point as a pivot point, and I'm going to pick my pin every time. if I pick this is my pivot point, remember force times distance? Well, we're going to do these all up, but then you're going to see some of those go away. So this is the point I'm going to measure from. This is my pivot point that my perpendicular distances are going to be. Okay, so what I have is I look at all these and decide whether they're clockwise or counterclockwise. Okay, I have an RAX. Is that clockwise or counterclockwise? It's going right at the pivot point. It doesn't have anything. My distance here is going to be 0. My distance here is going to be 0 because how far away are they from this pivot point? 0. So they're going to go away. So they're not going to go into my first calculation. So that means I have 1, 2, 3 moments. 3 forces acting on the truss, so they will each create their own individual moment. So now we're going to look at them as to whether they are clockwise or counterclockwise. This one, if you think about it, it's going to go, this one's going to go this way. So this one's going to be clockwise. So I'm going to have a moment at B. This one is going to go, also going to go down. It's also going to go clockwise. So I've got a moment at C. 2 clockwise moments. This one is going to go the other way. So they're going to have to balance each other out. This is going to be my moment at D. So my 2 clockwise moments have to balance out my 1 counterclockwise moment. So I replace each of these with force times distance. So B is, I'm going to drop the labels because I don't draw well with my pen. So I'm just going to say 500 times the perpendicular distance. Here's my force, here's my perpendicular distance, it's going to be 12. My C is going to be 600. And my perpendicular distance is going to be this way, so it's going to be 24. And over here, I don't know what the heck this is, so that's my unknown. I know that my distance is going to be this total, 24 plus 8, so 32 RDY. Okay? Now, you can, so when I multiply that out, I get 6,000 plus 14,400 equals 32 RDY. And when I solve that, I get R dy equals 637.5, and that would be pounds. Okay, so this is 637.5 pounds. So I know that one. Now, even though I didn't use them in this formula, I still need to find them. They're still there. Okay, so here's the deal. Sum of the forces in the x equals 0, sum of the forces in the y equals 0. So let's look at the x's. How many x ones do I have? I have an unknown x here, and I have a known x here. I only have 2 x forces, so they have to be equal and opposite. So that means that RAX has to be equal to this, but going in the opposite direction. So it's going to be a negative, basically, 500. Really, this arrow would now go in the opposite direction. 500 this way, got to have 500 this way. Okay? Down here, I got 637.5 going up. I have 600 here going down. So what's left over? Okay, I got 637, and you can do this as sum of the forces in the y equals 0, and then I can say I have 637.5 going upward. This is going down, so it's a negative 600 and plus RAY. Okay, 637.5 minus 600, 37.5. When I bring it to the other side, I get RAY equals a negative 37.5. So this is actually an arrow going downward, 37.5. Okay, that was a lot, and that was actually as complicated as they get. So an easier one is this one right here. I'm going to do this one right here. But, big but. She got a big but. I'm going to use this right here. This is my shortcut version that will help you in 90 whatever percent of the cases have it done correctly. So basically, I'm going to bring this over so you can see it. And we're going to follow these rules and solve the problem this way. Okay, so here's how we do it. First, draw reaction forces. So you're given a truss like this, draw the reaction forces. You'll see right here, 1 at the roller, 2 at the pin. So right here, I will R-A-Y, 2 at the pin, R-C-Y, R-C-X. Okay, we draw them towards the point. We start off always drawing them inward, draw to the point. We have to pick a choice. We have to pick a method. And then if we're wrong, we change the arrow. If we get a negative sign, it means it must have been the other way. And I'll talk about some people leave this and would just make a negative number here. Either way works. Okay, so that's step 1. Is there a force acting on the truss in the X direction? And by that I mean acting on it, not this one, but another one. Oh, right here, 140 pounds. So the answer to that is yes. If there is, the X reaction force is equal to it in the opposite direction. If it is not, the X reaction force is 0. If there was no force, if all I had was a force going down here, then this would be 0. But since it's not, this is going to be, so I'm going to say my RCX equals, it's actually going to go this opposite direction. I'm going to say a negative 140 pounds. So this is going to be 140. Okay, so that got that one done. Make the pin the rotation point. Okay, come over here, rotate, sit on it and rotate. Okay, that's my rotation point, because what that does is that makes these go away from my calculation. These will go to 0. Because the distance for this, whatever force this is at this point, the distance is 0. So that way I only have one unknown. That's what I like. I want one unknown, so I only need one equation. All right, I did that. List the moments acting on the rotation point, clockwise on the left, counterclockwise on the right. Okay, I got 2 guys, RAY and my 140 pounds. Those are the 2 that I have. RAY is going this way. So it is clockwise. So that is, oh no, we're just going to call it moment at A. And I got another moment up here, moment at B. This one is also going clockwise. Holy cow, 2 clockwise. How can we do that if I got my moment at B and I have no counterclockwise one for this equation? Yes, I know that's there, but they went to 0, remember? So we just have to set this equal to 0. There is no counterclockwise moment acting on that pivot point. Still works. Okay, so I did that. Replace each moment with a force and a distance perpendicular to the force. You should be left with just one unknown. Oops, we are. We're awesome so far. So basically, RAY, my distance is 20. So 20 RAY plus here's my B, 140. Perpendicular distance, that would be this way. So that's going to be 8 equals 0. Okay, so let's see, 8 times 140, 1120. So 20 RAY plus 20 equals 0. I bring that now to the other side. So 20 AY equals a negative 1120. Divide both sides by 20. And I get that my RAY equals a negative 56. Okay? So that means RAY is actually 56 pounds going down. So I got that one. I got that one. So what must RCY by? Well, let's see. Some of my forces in the Y direction have to add up, have to equal an opposite. And after you do this a few times, as I say, you can do this by inspection. I got one force going down. I must have another force going up. So this has to be 56. So again, RY equals a negative 56. RCY equals 56. And RCX equals a negative 140. Boom. These guys right here, it works. It works. I'm going to do one more, but I'm going to do it really fast. Okay? And you can follow along on your own. All right, so replace my, I want to be able to see, I want you to be able to see that and follow along as I go. So I've got, I keep losing my touch. Here we go. Oh, we got to label these. A, B, C, and D. So REY, RDY. The pin and roller do not have to always be on these sides. The pin can be over here. The roller can be over here. I meant to do one that was different, but this will still work. Okay, so I did step 1. Step 2, any X ones? Yeah, I got one right here, 240. So that means RDY has to be going in, has to go the other way. So it's going to be a negative 240. Bam, already done with one of them. I got 1 out of 3. You got a third of it done. You're killing it. Okay. Now I look at all my moments. Pivot point at the pin right there. These two go away. So now I'm going to have 1 unknown and 2 known moments. So I'm going to have, and this is kind of a weird one to label, but I'm going to have this one going upwards. So that's going clockwise. So my moment at A, this one, we're going to call this a B1 and a B2. So that I have, what I end up having is this one here is a clockwise moment. So I'm going to say plus moment at B1, and this is going to be my counterclockwise moment at B2. Okay, you can see that this is my pivot. This will go this way. That's my pivot. This will go this way. So there. So that's what we got. Okay, let's pop this baby out of here. All right, so my moment at A is going to be, here's my perpendicular distance, 28 REY. Moment at B1 is going to be 240. Perpendicular distance, going to be 12. And that's going to equal my counterclockwise, which is 200. And my perpendicular distance, that's going to be this one, 20. And this is a good example of, even though it's at the same point, perpendicular distance here is going this way, 12. Perpendicular distance here is going that way, so it's 20. Okay? And so we're just going to say, I'm going to kind of, and okay, we'll multiply it out for you. And then I'll finish it. So 240 times 12, 2880. And that is 200 times 20, so that is 4,000. And so 4,000, wait, 4, subtract out my 2880. And so I get 28 RAY equals 1120 RAY equals 40, exactly. Okay, so RAY, 40. Okay, so I got this one, I got this one. All I have left is this. So by inspection, look what I got here. I'll do it. Sum of the force in a Y equals 0. I got 40 going up. I got 200 going down. Whoops, so that should not be a plus. It should be a minus 200. And then I got my R dy. So 40 minus 200, that would give me a minus 160 plus R dy. Bring that to the other side, and R dy is going to be equal to 160. And think about it. 40 plus 160 going up balances out my 20 going down. Okay, that was a lot of work. I hope you got it.